Think about the image that comes to mind when we talk about the beginning of everything. Total darkness, and suddenly, bam, a blinding dot of light that explodes, creating everything we know. The Big Bang. Our idea of the beginning of the universe is, basically, a gigantic explosion. But what if this image is wrong? What if the story of our origin isn't about an explosion, but rather an eruption? What if we didn't come from nothing, but were literally spat out by a cosmic object so bizarre that our minds can barely process it? What if our entire universe is the exact opposite of a black hole? To be able to understand this crazy idea, we need to take a step back and talk about the most famous and feared concept in cosmology, the black hole. When Albert Einstein published his theory of general relativity, he gave us a new way to look at the universe. He showed that space and time aren't a fixed stage, but rather a flexible fabric, a mesh that mass and energy can curve and distort. Imagine a trampoline. If you throw a bowling ball on it, the fabric sinks. Now imagine a ball so absurdly heavy that it doesn't just sink, but tears the fabric and creates a bottomless pit. That's more or less what happens when a giant star dies and its core collapses under its own weight. It becomes a black hole. What defines a black hole is its event horizon. Think of it as a point of no return. Anything that crosses this line, a spaceship, a planet, even light, which is the fastest thing that exists, is swallowed by a gravity so brutal that escaping becomes impossible. There in the center, the theory predicts a singularity, a point with infinite density and gravity where our laws of physics simply break down. It's the cosmic end of the line, a place that only swallows, that only consumes, and from which nothing ever can return. Hold on to that idea. Now let's do something that theoretical physicists love. Let's run the film backwards. The same Einstein equations that predict black holes, when you work them in a different way, also allow the existence of an inside-out twin, a cosmic mirror, a white hole. If a black hole is a point from which you can't leave, a white hole is a place you can't enter. It's a region of space-time from which matter and energy can only escape, but nothing can penetrate. If you tried to send a probe to a white hole, it would never cross the event horizon. It would be like trying to swim against a cosmic waterfall with infinite force. The analogy is simple. Imagine the film of a star becoming a black hole, but playing backwards. Instead of matter collapsing into a singularity, we see a singularity exploding and gushing matter and energy into space. For a long time, this was seen only as a mathematical oddity. After all, we have proof and even photos of black holes, but we've never seen anything that looked like a white hole. And worse, there's no known process in nature that can create one. Black holes are born from the death of stars. White holes seem to have no father or mother. They were a solution looking for a problem. A door without a house. Until some scientists looked at the biggest mystery of all, the beginning of our universe. Let's go back to the image of the Big Bang. What does standard cosmology tell us? That the universe began from a singularity, a point of infinite density and temperature from which all matter, energy, space, and time emerged. Sound familiar? A point from which everything can only exit. The description is strangely similar to that of a white hole. This is where the theory gets spectacular, but it's important to remember that what follows is highly speculative and isn't part of the scientific consensus. The idea, which gains strength with theoretical models like loop quantum gravity, is as follows. Imagine a universe that existed before ours. In it, a supermassive star collapses, forming a black hole. Matter is sucked in and squeezed toward the singularity. But according to one of the interpretations of loop quantum gravity, the singularity of infinite density might never form. This theory proposes that space-time itself is made of indivisible pieces. When matter inside the black hole is compressed to this minimum scale, it can't shrink anymore. So instead of collapsing forever, it bounces back. A quantum bounce happens. the black hole, upon dying, would transform into a white hole. And this eruption of matter and energy, seen by those inside, would be what we call the Big Bang. Think about what this means. Our entire universe could be, hypothetically, the other side of a black hole that exists in another universe. This hypothesis, sometimes called Big Bounce cosmology, is powerful. It offers a possible answer to the question, what came before the Big Bang? Suggesting an infinite cycle of universes. It also suggests a solution to the information paradox. What happens to the information of matter that falls into a black hole? Here, it wouldn't be destroyed, but recycled to give rise to a new cosmos. We would be, literally, made from the dust of a universe that's already gone. The idea is incredible, poetic, almost too beautiful not to be true. But this is when we need to pull the handbrake of science and put our feet on the ground. At the moment, the hypothesis that the Big Bang was a white hole is purely theoretical and speculative. The heaviest fact is, to this day, there's no observational evidence that white holes exist. No telescope has ever caught one. Meanwhile, the standard Big Bang model is supported by concrete proof, like the cosmic microwave background radiation and the expansion of the universe, which we can measure and observe. Beyond the lack of proof, the idea has enormous theoretical challenges. The same calculations that imagine white holes also suggest they would be extremely unstable. The smallest particle of dust that interacted with a white hole could, in theory, make it collapse instantly. They would be the most fragile structures in the universe. Another huge problem is the second law of thermodynamics, one of the most sacred rules of physics. It says that the disorder of the universe, entropy, always increases. A white hole, which basically organizes matter and expels it from a singularity, seems to go against this tendency of the cosmos toward chaos. It's like seeing shards of a glass on the floor jump up and assemble themselves, with the water going back inside. The physics we know doesn't seem to allow this easily. So at the end of the day, was our universe born from a white hole? The most honest answer is, we have no idea. And maybe this is one of those questions for which we'll never have a definitive answer. But the search for that answer takes us to the limits of imagination. The idea transforms us from mere inhabitants of a universe to, perhaps, descendants of another. It suggests that the Big Bang may not have been a beginning, but a passage. That we're part of a cosmic cycle of death and rebirth, an eternal ballet of black and white holes. It's one of the most impressive stories that science has ever dared to tell, and even if it's just speculation, it reminds us that the universe is much stranger, more complex, and more wonderful than we dream. But what about you? What do you think? Could we be the result of the eruption of a previous universe? Leave your theory here in the comments. And if you, like me, are fascinated by exploring the greatest mysteries of the cosmos and the most radical ideas in science, you know what to do. Subscribe to the channel and turn on notifications so you don't miss our next journey into the unknown.